Hi, my name is Maurice CANNAVARO anak MOHD. So now I'm going to present to you about the problem statement for our assignment. So, our group has to design a simple projectile motion launcher that can shoot a ping pong ball using a mechanism. No rubber band should be used. The ball must start from point A, which is 0.124 meters above the ground. Using our projectile motion launcher, the ping pong ball should be shot at 45-degree angle into target number 2, which is placed 1 meter away horizontally from point A. To achieve this, we need to calculate the correct spring stiffness so that the ball has the right velocity to travel the required distance. We must also apply reverse engineering concept, show our calculation, discuss the result, and analyze how the launcher works.
Okay, my name is Dinendra Poobalan and I'm going to explain the group's projectile motion launcher. So this is our initial sketch and this is the completed ping pong ball launcher, which is quite similar to our initial sketch, whereby the cardboard, plastic bottle body and the ice cream sticks are used as the support to keep the spring mechanism and the ping pong ball at a 45-degree angle. It's important to keep this angle so that when the ping pong ball is launched, it actually follows the parabolic motion. Okay, then our spring mechanism is simple. It just uses bottle caps, which the spring is connected to and also supported by a stick, and the bottle head is where we store the ping pong ball launcher. So the working principle is simple. We use both of our hands to pull back the bottle head, and when we do this, the spring actually compresses. Once we remove our hands, the spring retracts back and it creates the reaction force which pushes the bottle head forward and hence also pushes the ping pong ball and launches it. Now here's the proof video that our ping pong ball launcher, which was set at a height of 0.124 meters, was able to actually shoot the ball at a parabolic motion over a horizontal distance of 1 meter into the second target.
Hi, Assalamualaikum. My name is MUHMMAD dari HAZIQ bin MOHD DAUD. Today I'm going to explain how we can find the spring constant or K using the Hooke's law. In the experiment, we had a different weight on a spring and measured how much is stretched. The force of each weight is called F and its strength is called X or extension. We record the volume of X and X into the table, then we plot the graph of the force against extension. The graph shows a straight line, which means the spring follow the Hooke's law. The formula is simple. F equals to Kx. So if we rearrange it, we get the K equals to F over X. From the graph, we find the gradient of the line which gives us the spring constant. In our case, the gradient is 336.43. So the spring constant is K equals to 336.33. This tells us how the stiff spring is, and the higher the value, the harder its stretch. Thanks for listening.
Good evening everyone, my name is VISHNURAAM. In this presentation, I will explain how to find the initial launch velocity of a ping pong ball using the equations of projectile motion. In this slide, the objective is to find the initial launch velocity of a ping pong ball. The problem is solved using projectile motion equations where the motion is separated into horizontal and vertical components. Since the ball is launched at an angle, the initial velocity is resolved into VO cos theta in the horizontal direction and VO sin theta in the vertical direction. These components allow the use of kinematic equations to determine the unknown initial velocity. The next slide shows the known values used in the calculation. The gravitational acceleration is 9.81 meter per square acting downward. The ball is launched from an initial height of 0.124 meter above the ground. The horizontal distance to the target is 1.0 meter. The launch angle is 45 degrees, which defines the direction of motion. The final vertical displacement is 0 because the ball lands on the ground. All these values are substituted into the projectile motion equations to calculate the initial velocity. Thank you.
So now, I'm going to present about finding needed compression of spring X. Apply the conservation of energy. The elastic potential energy stored in compressed spring is converted into the kinetic energy of the ping pong ball. From this, we can rearrange the equation to find how much the spring need to be compressed so the ping pong ball can enter target number 2. So here, V is equal to 2.95 meter per second. M is equal to 0.0267 kilogram, and K is equal to 336.43 N per M. Since the K and required compression X is known, the required applied force F can also be found. The required compression is equal to 0.0263 meter, and the required applied force is equal to 8.85 Newton.